Hello, today we're going to be talking about forecasting the weather. So the objectives for this unit are going to be to learn about instruments used in forecasting the weather. We're going to explain how radars and satellites help meteorologists forecast the weather. So radar and satellites are going to be probably on the quiz, so remember to write some notes down about that. And then a meteorologist, this is important, is someone who interprets weather data and makes predictions on that weather data for future weather. And then we're going to learn how to interpret weather maps. All right, so forecasting, a little background here. To forecast is to make a prediction of the future weather by interpreting atmospheric data and weather patterns, and that's reliable for about 3 to 5 days. So if someone tells you that 14 days from now it's going to be sunny and clear, they don't know what they're talking about. It's really hard to predict that data outside of 3 to 5 days. And then 1 to 2 days is really easy, so we don't really put that in there. So we use weather balloons. The weather balloons are sent into the higher troposphere and the lower stratosphere, and they carry radio transmitters that send weather data such as atmospheric pressure, temperature, precipitation, certain things like that, wind speed, to weather stations on the ground. So there's a bunch of weather stations all over. They send weather balloons out all the time, and they're constantly getting data. So that's how they get their models. And then how to measure air temperature and atmospheric pressure. So a thermometer, I hope you guys all know this. A thermometer is how you measure temperature. I'm not going to get too much into it. It doesn't really matter for this unit. And then a barometer is how you measure atmospheric pressure. So this little bar here is just going up based on how much pressure it's recording from the atmosphere. So we've got some other technologies that we use. We use weather vanes or a windsock that's the same thing to determine weather direction. Right here is a weather vane, with the classic rooster on the top. You see that in like tornado movies. It's just like spinning around in circles. And then we look at anemometers, which measure wind speed. And this up here in the corner is an anemometer. So it's got a little generator that generates electricity. So we know how much pressure or how much wind speed it takes for these revolutions to generate energy from this generator. So however much energy comes out of this generator is how fast the wind is going, because these cups catch the wind and they just spin and revolve and then turn this generator. And then they use radar and satellites, like we were talking about. Those are going to be things that we're going to learn about. Um, they're used to find the location of weather events, movement, and amount of precipitation that is falling. So that's a radar. Radar is going to be measuring the location of weather events, the movement, and the amount of precipitation that's falling. And then satellites are going to provide images of weather systems. It's going to be able to track storms at different altitudes, which way they're going, how fast they're going, and then they use radars to determine, how much rain is falling, stuff like that. And so that's how they create their models as well. And so they have these things called weather maps that meteorologists look at, and they are made by the National Weather Service in conjunction with the National Oceanic Atmospheric Administration. So this is really just like a bunch of guys on boats and then on the coast taking atmospheric data. And then the National Weather Service has weather stations all across the nation. And they make the models from weather data that we get from weather balloons, anemometers, barometers. All that stuff is put together to make one big model for the whole nation. And that's how they make weather maps. And so there are things called isobars, which are lines on the weather map connecting areas of equal pressure, so high or low pressure, and I will show you those now. So here, maybe a little difficult to see, but here on this map, we've got these white lines here. Um, in between these white lines, they connect, they go all the way up and come around. We have H, which means it's a high pressure system. So in this white line here, this circle, it goes around, it connects, and then it comes back down here. is a high pressure system. And so then in this system right here, this is a high pressure system, and then around here is another high pressure system. And so then we'll show you an example of a low pressure system with the L here. It's this little white line, it goes all the way up and it comes right back down and around. So all these states are experiencing a low pressure system. So you're going to see a lot of instability in storms. And then here are just like fronts. And we talked about these in a previous unit, but here's a warm front. Remember we said that this kind of looks like suns and the sun is hot, so it's going to be a warm front. Um, so that's just an indicator of a warm front. The cold front kind of looks like icicles here. So that's what we call a cold front and how that looks. And then the occluded front is when they're kind of pushed together. Um, and that's going to be cold, warm, cold, warm. And a stationary front is when they're not moving at all. So there's a warm mass between, or a warm mass and a cold mass, just kind of like touching each other but not pushing. So that's the cold mass there, the warm mass there. So that's a stationary front. So that's not super important, but it's just additional information. And here you can see in this low pressure system, we've got an occluded front, which are linked to cumulonimbus clouds and storms. So that's what you're going to see in low pressure systems. And then we've got a cold front here and a warm front up here and over here, and then a stationary front, it looks like right in there. So, oh, here's a stationary front. So, that's how they make the predictions on the weather. I could do it right now based on this weather map, and now so could you probably with um, a little bit of discretion. All right, so that's all you're going to need to know for forecasting the weather. Like always, call, text, message if you have any questions, comments, concerns, and I hope you all have a good week.